Okay, good morning, everybody. Thank you very much for attending my second session. This one is not that frightening. It's a positive session with tons of interesting information. And we focus today on clientless SSO for BYOD, bring your own device, and other unsupported on or unmanaged platforms. Let's start. Let me remind you about my yesterday's session about authentication, because we've been talking about authentication factors, or methods, and about the fact that authentication is a, let's say, special case of authorization. Yeah. And I mentioned yesterday that authentication factor can be virtually anywhere. It can be your location, it can be your username, password, etc., etc. You simply choose whatever works the best for your users, not for you, for your users. That's important. And authorization can be a user specific or not specific. Very nice example is the piece of paper you've got in your conference bag, because very probably we all use one username, T-conference. If anybody got different name, probably not. Yeah. So this is not user specific, but it is authorizing us to use connection to the internet. That's it. Yeah, probably nothing else. But that is exactly easy, but still example of clientless authentication and SSO, because the first is to authenticate to the Wi-Fi network, but then you need to go through some firewall outside. Yeah? And it should not be automatic, especially because we are Germany. Is somebody here from Germany? No, nobody. You. So you know that the laws here in Germany around internet access are a bit strict. And what can happen that you can enjoy a dinner at a restaurant, you ask them, can I use your Wi-Fi? Yes, but you need to get a ticket and we need to know who you are, because if you start sharing some unlicensed content from our restaurant, we can run in problems, so we know who you are. We need to know who you are. Maybe you remember several years ago, there was a big case. Somebody, I think it was in Düsseldorf, somebody been visiting a book shop, a library and cafeteria there. And that guy connected to the internet and I think he'd be sharing some movies, and big US studios, open a justice court case, and the first was that they asked the bookshop for the money. You remember it? And bookshop, no, you are too young, maybe. And the bookshop said, oh, it's not our problem, because, there was a guest. And at the end, they start, let's say, investigating who is using the connection to the internet. So at least this building, if anything like that will happen, hopefully not, who knows, at least they can say, okay, it was somebody using the name T-conference. That's better than nothing. Police can investigate. So, excuse me. So what are the options to authenticate the user and provide the user with SSO without a client? Nobody can enforce you. Oh, you are at the conference, you need to install a client and we will configure it, blah, blah. No, it's even not legal. Yeah, that's not possible. But still, the users are connecting using Wi-Fi, like we here, or using VPN from the outside to the internal environment. This is pretty common for schools. We have many customers, schools, colleges, universities, and that is exactly what do they do. If the students is on site, Wi-Fi. If the student is at home, VPN with the same object in the, I don't know, directory, e-directory, Active Directory, whatever directory. So VPN and Wi-Fi is a good option for us. VPN, not today, but for many years, is usually two-factor. Yeah, it's not just one factor, but two-factor. Even if you use just username and password, there is a first stage of the authentication, and together it's a two-factor. Wi-Fi is usually one factor, but of course you can extend it by smart approach. As I mentioned yesterday, a second factor for your authentication can be the location, because we simply know that we are here inside the perimeter. You cannot connect to Wi-Fi from home at this building. So the trust level of this authentication is not just one factor, but maybe 1.5 factor. Again, as I mentioned yesterday, you can have a, can you please close the door? Just to thank you very much. So in fact, there is a box or a virtualized box. It can be firewall, it can be Wi-Fi central, or each Wi-Fi access point can do it without a central control unit. And that box knows who is the user. As I mentioned yesterday, the idea from Google, from Zurich, they said, oh, we have to authenticate to VPN, which is pretty abusing. And then we have to do it again, to authenticate to our system. And the idea was, let's avoid one pretty same authentication, and let's work with the VPN authentication only because it is secure enough. So the question is, can we work with this information if we have the matching object? Because you need to know, okay, this is the authentication and there is the matching object in the directory. This is the user. Because this box knows everything. It's not about the initial authentication only, but the box knows if the user is still there, if the user is working, or if the user left, or the connection was canceled. It does not matter who canceled or stopped the connection, simply it's not there anymore. So everything you can learn from that box. And very nice, there are some boxes and they understand just JBoss, but 99% of boxes today speak Esperanto. You know what is Esperanto? Before English, there was the idea of Esperanto. Yeah, it's pretty old. No, I mean before English became de facto Esperanto. Sorry, that's what I mean. Yeah, because today we use English as a universal language, for communication, and that Esperanto is called radius accounting. So you can check, of course, if you buy your VPN at Aldi for 20 euros, maybe it will not speak radius accounting, but trust me, VPN for 20 euros is not the right device for your environment. Yeah, maybe it's not even the right device for your home. First of all, again, let me make sure that we are tuned on the same frequency, because when people hear radius, they expect something different. That's like if you hear Java and JavaScript, and if you do not know what is the difference, oh, Java, JavaScript, that's, yeah, Java, I can do it. No. No, I don't know why the hell they use JavaScript, but it's different. So radius and radius accounting is totally different. So just to remind you what the radius stands for, it's remote authentication dial in the user service, and it's a client-server protocol invented or established in early 90s. You can refer to this RFC if you want to learn more, but you do not need it for authentication. This is just for your reference. I put all the information here. And the client, you know, is generally named Network Access Server, NAS. And when you want to get in, that server used the radius protocol and queries the authentication server to check, you know, provide your username and password, and then you get authorized and configured. That's important. Also configured. So not only for the authentication, but also for configuration, what the user can do or what the client for the user can do. And again, important, this has nothing with radius accounting. Absolutely nothing. Just this word is there. Okay? Yes, sir.
Radius, and there's two parts of radius. There is the authentication side.
Radius is, I would say, predecessor of LDAP, for example. But this session is totally not about radius. This slide is the last slide about radius. No worries. So let's switch to the next slide. And that's what is radius accounting. And that's a special protocol. And a purpose of this protocol was to build the user. Maybe you remember, if you are old enough, 25 years ago, you know, you tried to dial in, there was a modem, and when you were lucky enough, you establish a connection, and then the radius accounting server start billing you like 10 pennies, you know, per minute or something like that, whatever. I've been using IBM, for example, for this. So the idea is very easy. They did not want to charge you if there was no connection. So the client, when the client was really connected, able to communicate, then the client, not the server, the client, your client on your device said, send the packet, I'm here, start. It was like ting, 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 and your account, you know, been growing. So, and the client also said, okay, I'm leaving, stop accounting. Of course, especially with modem, you can lose connection very easy. So that's why there is also so-called interim update. That works in that way that the clients by default every 10 minutes says, I'm still here. You can continue counting or accounting. Yeah. So if the accounting server, again, not the radius server, yeah, not NAS server, but the accounting server gets no interim update, it says, okay, stop. So what can happen, of course, that you lost the connection within from 0 to 10 minutes until the next interim update, and they count you a little bit more, but that's okay. So this is what we can use, and we can really use very easy because it's built in. You can go to the configuration of your VPN. Just look RA. That's quite often used, RA, or maybe radius accounting, the full words. You can find it and say enable, and this is the address of my server.
Oh, we're large education institutions here. And I don't know whether it was the case with BYOD in Europe. In the United Kingdom, we block radius accounting packets because they're not.
I definitely have more than one customer in the UK. They use this, and they are very happy with that.
Yeah, but typically, if you're using EduRoam, for example.
Oh, yeah.
Most likely to be used. It's discouraged from
Yes. If you want to use this, it must work. But for students at a big college, for example, they do not use eduroam. They have own internal accounts, and that works. Those start, stop, and interim update packets are protected, so that the content of the packet is hashed, and it's hashed with a pre-share secret. So pre-share secret means that you generate some string, and you copy the string, you set it at the server side, you set it at the client side, and then they can understand each other. Okay, so when you monitor your network traffic, you can see the packets. You cannot see the content. If you want to read what is in the packet, you need to know the pre-shared secret, and then you can check. So maybe there are some doubts about the security of this, but not really in your server room, in your networking room. Yeah, there are, let's say, no doubts. It simply works. Yeah. There are some standard attributes. In fact, you can add anything you want in those packets if it's possible. Most of the devices, there are no options, nothing. That's simply built in, and that's it. Some vendors provide vendor-specific attributes. Yeah, so if you compare Cisco and Fortinet, it's not the same. But these attributes are always there. I never ever seen anything not providing these three attributes. Yeah? So this is matching the object in the directory. That's the IP address. It's set to the client, and group membership is used to control what the user or the user's device can do. Yeah. So also there is always the same port, same IP address. So one attribute says this is start or stop or internet update packet. That's it. So your NAS device can be virtually anything, but what you probably have in your network is a firewall. It can be cloud firewall. It's the same. We have a customer, they use Cisco Cloud. It works. Just ask the provider, please send radius accounting packets to this IP address. Done. It works. Okay. And that's the same with Wi-Fi. You can have separate APs, or there can be a structure controlled by a central, or again, the control service service can be cloud-based. Again, the same. You just ask the provider, please send me radius accounting packets. Here is my pre-shared secrets. Here is the address of my server. That's it. I mean, radius accounting server. Of course, in some countries, it still can be a modem pool. Why not? And I've been last time in Africa, I've seen modem pool. It works. We just do not use it here in Europe. Last country where I seen modem pool was Romania, but it was many years ago, and I think they do not do it anymore. So what the user can use? Anything. If we use Wi-Fi, anything you can use to authenticate to Wi-Fi network is the right device you can use. Regardless the operating system, the producer, anything. If you can use Wi-Fi and you can authenticate such a piece of paper, you can use it for with your NAS. So it can be Windows, Mac OS, Linux, it can be laptop, it can be mobile device, it can be your own device, or it can be a device owned by the organization. Specifically, why we start working with this, Chromebooks. Customers in the UK, they quite often have hundreds or thousands of Chromebooks, and even it looks like Android, it is not the same. So first we tried to develop a client for Chromebook, and we discovered that that's a suboptimal strategy. So we changed our mind, and with one of our customers, we designed this solution. And now it's pretty generic. And once you are in, of course, this is not about reduce accounting, it's about KeyShieldSSO, but with KeyShieldSSO, once you are in, without a client, you can use SAML, JSON Web Tokens, OpenAuth, whatever you know, to authenticate to various SPs inside or outside. So if you want to authenticate to Wi-Fi with your school account, let's say, university account, then you can just click and go to your Office 365, Google, whatever, okay? Without any further authentication. You are in, yeah? Of course, the identity of the user is connected to the IP address the device has at the moment, because as we see in the radius accounting packet, it says this username, this IP address. Yeah, and if it keeps sending interim updates, you simply know that the user has that IP address and nobody else has that IP address. So with Chromebooks or whatever, yeah, they connect, there is a pool of addresses, and it goes like, oh, I'm first, second, third, and I get IP address from the pool. That's it. Yeah. So you configure your device, your NAS, say, okay, here is my pool of addresses. Yeah. And at the moment, one device has one IP address. Of course, it does not matter if it's a firewall or Wi-Fi. It works in the same way. Yeah, firewall is a little bit more secure, but it depends. It's if we have the device, we need Radius accounting server to receive packets and work with those packets. Generally, it can be any device supporting the server-side role. So maybe, I do not know, I did not start hacking this network yet, but maybe here is Wi-Fi, and it sends Radius accounting packets directly to the firewall to open the way out for you. Yeah, and that's a typical configuration, or that is something you can do because most of the devices can work with just one server. Yeah, so you can send the packet to one server only. That makes sense. Some devices can work as a client and as a server at the same time, because if you have firewall, it would be great if on one side you can send the packets when users connect to VPN, but because it's a firewall and it does everything for you, it also would be great if it can receive packets from other devices and open the way out. And that's one reason why packets also contain information about the group membership, because the groups can be something like no internet, limited internet, unlimited internet. In the UK, they call it unwanted content. Here in continental Europe, we call it porn. So you can block the users, yeah. And the reason why is that by law, if the user is below 18 years, you must protect the user against unwanted content. Yeah. So once the user turns 18, then the user can say, okay, I'm adult legally, and I do not want any protection anymore. It depends, but legally you can do it. So you can say, okay, now the user will be in the group no limit. So it is described how it can work and how it is with the groups. So again, some picture. It is very easy. Unfortunately, I use the word group here, but that's totally different group. With firewall, with VPN, you know, the first factor of the authentication is the confirmation of the identity of the device. Yeah. So yeah, you can use SSL, but with IPsec you got a profile, PFC, for example, and it contains the identity of the device. So first, your client confirms the identity of the device, and then you can use your username and password. As I already mentioned, the quality of the authentication to VPN is quite high because it's two-factor authentication, and usually it is against your user source. Some devices can even work with more than one, yeah. And then you manage the authentication. You can disable users, you can enable users, you know, you can change the password, etc. So it's really secure. So the quality, the trust level of this authentication is high. So as we have seen yesterday, in fact, you know, one IDP can learn about the user's identity from other IDP. Yeah. So if I trust the other IDP, I can just learn, and I do not need to do any further authentication. And this is the case. So if I talk about KeyShieldSSO in my examples, KeyShieldSSO learns from the device, from the firewall, who is the user, and that's it. The only check we do is that we are looking for the matching user in the source, just to make sure that we can work with the user, because firewalls, they usually allow you to use a local users. You know, you can work with a user source, but you can also enter some accounts directly in the internal database of the device, but that's not that secure, because, you know, it's controlled manually. So you can limit the users you will allow to, you know, authenticate to further services, etc., to the users from your user source only. So local users are ignored, because if we cannot find the matching object, we ignore it. If there is a matching object, we trust it. That's how it works. Yeah. So once the user gets authenticated this way, KeyShieldSSO checks if there is a matching object, and then KeyShieldSSO also can distribute packets to other devices. So we can multiply. I'll show you later how it works with some drawing. So you might have more devices, like firewall to let the device go out, proxy, web content manager. It depends, and you need to inform them all. And that's, let's say, about the authorization or about a monitoring, because sometimes you do not want to authorize the users. You simply know if the user can authenticate successfully like this, and it's okay, the user can go out, but you must monitor, let's say, the sites where the user goes. Might be about the regulation, your internal rules or whatever. So many people use web content managers or proxies to keep logs and to in fact, to monitor what users are doing. Yes, sir.
It's getting a bit harder to do that. You're not necessarily using.
I'm a tech guy. Yeah, technically, it's doable.
Yes, but you've got to look in. Technically doable, but you're allowed to do it. Question.
Yes, but not for me. Not for me. I agree with you. I just tell you, you can do it. It's your decision if you will do it or not. Yeah, that's so. You know, even if you have users sharing one device, one computer, you can change the group membership at the firewall or the device and manage what the user can do. We can map radius accounting groups to LDAP groups. So we go through the source. Oh, the user is a member of adult students, you know, over 18 years old, and we send. We do not provide this strange full group name. It doesn't work. We have a table which says send unlimited, and the group is unlimited, and it goes. Very easy. Yeah. We also can do it dynamically. We do not have enough time to talk about this, but that's like, because many tests you can use, you know, testing solutions are outside. So you want the students to do the test, but you do not want the students to consult Google or AI or whatever. So you can have a special group which lets the users from one classroom, for example, to go to the test site only, nothing else. Yeah. So you have the group, and the teacher can just click on a button, and all the users present in the room, in the classroom, you know, that we send extra radius accounting packet, let's say to firewall, and we say, okay, add this group to this user, done, and the users cannot go out except the testing side, and then the teacher can stop it, and again, bunch of packets, and the users can go out again. So this is very strong feature. Yeah, nothing fancy, nothing crazy. It just works with existing features of most of the devices. Yeah. KeyShield is pretty flexible, so you can create as many configurations as you want. So KeyShield can serve as a radius accounting server for different clients and can serve as radius accounting client for different servers. That's almost not limited, and it can look like this. Yeah. So you have one device, one KeyShieldSSO, yeah. And if it's a server, it is receiving radius accounting packets from different sources. Yeah. It does not matter how many sources you have. You simply receive the packets. Once the user gets authenticated, we send radius accounting packets to other servers, like I mentioned, web content managers, proxy, firewall, whatever can work with radius accounting. Yeah? If we get a stop packet, means the user is not there anymore, or if we not receive expected interim update packet, again, we send a bunch of packets to these servers to inform them that the user is not there. Stop, done. Very easy. This is perfect for not only for your regular users, but also for guests like we are here in the conference, in this conference. This is how it works. The firewall sends a packet to KeyShield, or during the connection interim update, or at the end the stop packet. Easy. KeyShieldSSO is taking care about the uniqueness of the IP address. So if the IP address is not unique, then it doesn't work. This protection is there from the beginning, so the IP address can really be used for authentication. With latest KeyShield 8.6, there is an improvement, and I will mention it later. So as I had in my previous drawings, we have some clients, and it does not matter how the client authenticated. Of course, in terms of this session, that was radius accounting, so we know the name of the user and the IP address, the unique IP address used at the user, used by the user or by the user's device, and we work with that. And if the user is there, we have some direct integrations like Filer. Filer has different, let's say, interfaces. You can work with the web client, you can work with the local client. There is, in fact, REST API. So it is not that easy, because if it would be just a browser, you can use SAML or anything else, and that's okay. But with different protocols and different interfaces, that is not that easy. So that's why, since the beginning, we use IP address for authentication to Filer. Maybe during this conference, we are not going to use Filer, even if something here is installed. But imagine, iPrint. As a conference attendee, you might be allowed to use a network printer here. How to do it? Of course, it is not that smart to let anybody to connect from the mobile phone to the printer and print tons of paper. But you can authenticate to iPrint using, your authentication to Wi-Fi. Then, even it is a generic T-conference user, that's not a problem, because we just need to authorize somebody to use the printer. We do not need to, know if it's me or you. So it can be used for various scenarios, and Filer is perfect example. But we also support SAML and JFrog components and OEDC. When you remember the session yesterday, it was working with the browser. So a standard way how IDPs are working is that when you connect to IDP, let's say IDPB from the yesterday example, IDPB first, what it does first? Sorry? Oh, it asks the browser for cookies. So that's the standard way how it works with the browser. So IDP asks the browser, have you any cookie or this cookie? Give me the content of the cookie. And the content of the cookie is usually some token which says, oh, we know who is the user. So next connection, and you do not need another authentication because your token is still valid. and IDP can get the information from the browser. It can be another session with the same browser and it works. But if there is no information, then usually the IDP reacts like, give me your username and password, as it was in the example. But here, because IDP is KeyShield, yeah, KeyShield checks two things. You can authenticate to KeyShield with a token. If there is no token, you still can authenticate with your IP address. So if the communication comes from known IP address, we simply know that this IP address is now owned by a specific user. We can work with that, and we do not need to ask who is the user. This works really good, yeah, and we do not know about any, let's say, security issues related to that, especially because of the way how we work with IP addresses, and we even have new option. It's there since 8.6, and we call it an IP address hardening, yeah, and it works in that way that by default KeyShield checks. You can reconfigure this, but if you do it more often, then it generates a lot of traffic. So the smart idea is to keep it 2 minutes, but use the hardening option. And hardening option works in that way that you can say, okay, if the user comes from this network, from this pool of addresses, before you work with the identity of the user, check the user. It adds some tens of milliseconds, maybe less, yeah, to response time, but it's really secure. And it was implemented originally because of some stupid NAS, which is not working in an optimal way with the pool of addresses. There was no delay, and they reused the address. So it was like, ping, within 1 second, it changed the user behind the IP address. But with this option, that's no problem, because we check who is the user and we know who is the user. So if the user is not there anymore, we remove the information about the user second, and another authentication must come. Usually it works in that way that we remove the user, and in next 300 milliseconds, we get new radius accounting packet. Oh, it's not Václav anymore, it's Joe. Please.
You still have an issue with
with using terminal service, there is an option which allows you to use at the level of WinSock separate IP address for each session. So we recognize it, and if this option is not active, it doesn't work. So it's an issue, but not a security issue. You need to change the configuration of your terminal server if you want to use this. So the schema says how it works. Yeah. First, as we have seen yesterday, we have a browser or the embedded browser. We knock the door of the SP. Hi, I want to work with you. But because the SP does not know who is the user, here is no token. No, cookie is expired. It redirects the browser, redirects the IDP, and it's KeyShield in this case. And KeyShield needs to authenticate you. No client, yeah, but we work with the IP address. So we know who is the user. We prepare the assertion. Assertion is an XML, signed XML file which informs SP who is the user. And we redirect the user, the browser, back, this time with the assertion in the header, and you are in. It's fast, it's reliable, yeah, it works very good. Of course, we do it with the client also, and this is general implementation. So we worked with tokens. It needs little bit more communication, but the beginning is the same. But when KeyShield work with token, it asks, give me the token. Here must be the extension, KeyShield extension. It talks to, in fact, you know, it does not talk directly to the client. There is so-called native host in between. So it talks to native host talks to the KeyShield client asks KeyShieldSSO on another connection, give me a fresh token. Token is delivered to the extension delivers the token back to KeyShieldSSO. It checks the validity of the token, then it knows who you are and redirects you back with the assertion. Of course, when you want to use IP addresses, you must be physically or virtually inside the perimeter. So you use VPN or Wi-Fi. You are inside the perimeter. This works generally from anywhere. So when I travel, for example, I use my KeyShield client and I authenticate myself to anything, including file, including group-wise, whatever is integrated. Of course, our secure anybox is among the integrated SPs. So this is working generally. The previous works inside the perimeter, but needs nothing. Yeah. Oops. Last 2 slides. So why this session? It's like, you know, I see the nice information over there. No need for new infrastructure. You see it? Use existing server. No need for new infrastructure. My impression is that OpenText thinks that's important information for you. You do not need to buy anything new. You just can configure it in a new or smart way, and that's it. And this is exactly the same. If you check the devices you already have, I promise 99% it's there. You just need to click enable and put 2 information into it, and it works. Yeah. If you have KeyShieldSSO already, we have customers here, they can use it within 5 minutes. That's a seamless, you know, nothing, no client, no delays. You do not need even to abuse the users. You can give them this, and they do not know what is behind. Of course, it's not a secret. You can tell them, but they simply do not need to take care about that. So that is very easy for authentication, but also for statistics and monitoring, especially if you must monitor or if you can monitor. And the last slide. So that's just the comment about the situation. Of course, it is different country by country. Yeah. So it's your decision what will you do, but generally, you know, you can manage what the users authenticated to your VPN on your Wi-Fi, what they can do and what you can let them do. Yeah. That's important, that the basic idea is not to allow them to do something, but to define what they can do. Yeah? And keep your environment secure enough. You do not need to open anything like, oh, I want them to be able, you know, to print, so I have to open it generally. So that's it. Yeah. Again, I'm here till Friday, free of charge. We can discuss anything. Yeah. Don't worry, you know, our prices are very friendly, but still, since Monday morning, I do not work for nothing. So we can discuss detail. That's about the radius accounting, and that's my today's session. Tomorrow I do 2 sessions, a little bit more frightening than this positive session. So thank you very much. Thanks.